It's 17 incredible 3D printed objects. Beauty the bald eagle was shot in the face by poachers, an attack she survived but ultimately left her debilitated. Without her beak, she had virtually zero chances of survival. That's when raptor specialist Jane Cantwell and mechanical engineer Nate Calvin stepped in with a specially designed 3D printed beak prosthetic. With this new beak, Beauty will be able to live a life as if those poachers never attacked her. Speaking of prosthetics for animals, probably one of the most famous cases was made for Derby the dog. Derby was born with deformities in his front legs, which made it hard to impossible for him to be mobile at all. His caretakers even considered euthanization as the only humane option for him. Peace and Paws Dog Rescue discovered Derby and took thousands of CAT scans, which was used to construct special 3D printed prosthetics that allowed Derby to run as far into the hills as his little puppy heart desires. M.C. Escher is known for his impossible drawings and illusions that fool your eyes with 2D drawing tricks. Well, this computer science professor from the Israel Institute of Technology has manipulated these illusions so that they could work as 3D objects. They fool your eye the same way Escher's 2D illusions do in one angle, but if you turn it to the side, you'll see the secret to their trick. This is Irby, the world's first 3D printed car. It has humble beginnings as a small project by an independent team of designers at Core Ecologic. The team wanted to design an environmentally conscious and sustainable car that could take a couple of people and their pet from one end to the US to the other on just 10 gallons of fuel. The best way to get this uber eco-friendly machine was to 3D print all the parts and assemble those. It is one of the greenest cars ever made, and a sequel, Irby 2, is in the works. When you think about people who are into 3D printing, you probably imagine a bunch of geeks already. But this might be the epitome of geekdom, and I mean that in the best possible sense. Stephen D. of Crimson's Cost Crafts used a 3D printer to make an exact copy of the Dark Knight's gothy armor from the Batman Arkham Origins game. If you think about it, using expensive technology to make some sick superhero armor is very true to the character for Bruce Wayne. 3D printing is now part of the world of jewelry, and it's not just cutesy plastic novelty jewelry either. Visitors to American Pearl can create and customize a ring or any pearl or diamond you want. Who says 3D printing is just for geeks with niche interests and making prosthetics? .3D printing even gotten its hand into fashion. It's allowed for more daring and impossible-looking clothes and pushes the edge of what our clothes and bodies can look like. Designers like Chanel and Karl Lagerfeld are utilizing this technology to create weird, alien, and exotic-looking pieces. While most of these pieces are hanging in the Met and off of models like Dita Von Teese, they could soon be coming out of your personal printer at home. Making clothes right out of your home office might just be the next step in fast fashion. You've seen 3D printing make fashion garments and body prosthetics, so it's not too much of a leap to imagine a 3D printed organ. Scientists at Princeton University designed this bionic ear that can actually hear even better than human ears. The 3D printed cells and nanoparticles with a small coil antenna creates this cyber ear that can be installed into a real human and hear radio frequencies a million times higher than our own ears. Jake Evell was a recent graduate of Victoria University when he broke his hand and was stuck with an arm cast that he found archaic. So, he designed a cast for the millennial, a 3D printed, lightweight, washable, and breathable. That age-old feeling of gross itchiness and suffocation the usual plaster casts come with. Plus, they just look super cool. Try explaining to someone from 10 years ago that NASA funded a 3D printing object to print pizza. Well, that's the reality we're living in today. The company known as BHEX was commissioned by NASA to develop palatable food for astronauts' deep space journey to Mars. The printer can create specific flavors and toppings, and even shapes based on scanned JPEG files to keep those bored astronauts appeased on their years-long journey. Humans aren't scheduled to make any trips to our sister planet until the early 2030s, so we'll probably be seeing these printed pizzas at theme parks and novelty restaurants until then. The shakuhachi flute is a beautiful Japanese flute from the ancient Edo period that is classically made from a bamboo shoot. In 2016, you can now 3D print one out of stainless steel with matte or gold finishes and an intricate dragon design. You can own this ancient instrument for as little as $240. 3D scans of your unborn fetus can be a little confusing to look at or understand. Now, you can get a 3D print of your fetus to hold and touch and see for as little as $1,275 US dollars. A Japanese company will create a small sculpture with a software called biotexture. If you're into instruments at all, you're probably aware of Stradivarius violins and string instruments renowned for their well-made instruments. The 3D Various violins bring that model to the modern age with a slick 3D printed polymer design and funky synthetic sound. While it is based on the Stradivarius violins, its goal was to be its own unique shape and have its own unique sound. Now here's something I'm sure none of us thought would ever exist: a tampon magazine. It's meant to make you have fun and feel cute, storing your tampons in a hyper-femme bullet-style box, letting you shoot them out whenever you need. It isn't really space efficient or practical, but it's a way to bring something fun into what is arguably the worst time of any lunar cycle. Surgeons and medical practitioners often have to practice procedures on dummy models or cadavers. But as you can imagine, those options are either slightly inaccurate or expensive and a limited resource. Now, with 3D printed models, practice dummies are easier to come by and more accurate, which is great for patients and surgeons alike. When you think about 3D printing, you usually imagine printing little gadgets, life hacks, and little things that make your life easier. If you take that to its logical conclusion, you might wonder if we'll ever have 3D printed buildings and housing. Well, we do, and they were printed and constructed by Winsun in China. These two buildings were constructed from parts entirely made with a specially made 3D printing technology, including the plumbing, wiring, and entire foundation.
And now for number one. But first, be sure to subscribe for new videos every day.
This camera, including the lens, was made completely with a 3D printer, and it actually works. Camera lenses are made from either acrylic or sandblasted resin, and it has all the moving parts that allow you to change aperture, load, and unload film. The photos that come from this 3D printed camera aren't exactly crisp or super pristine, but they have a dreamy quality about them that you wouldn't expect to come out of a handcrafted camera.
Three-dimensional printing has been around since the early 1980s, but has really taken off in just the last few years. Today, it is being used to make things like machine parts, jewelry, souvenirs, toys, or even a 3D printout of a fetus in Japan. China is taking a revolutionary step in 3D printing. Researchers in Hangzhou have unveiled the country's first 3D bioprinter that can make human body parts, a move that has raised ethical questions for some. Here it is carving out a pair of ears using biomaterials like cells that are placed inside the cartridge. The finished parts are then put into containers for storage.
Compared to other 3D printers, our device is equipped with a spray head that can rotate from -5 to 260 degrees. It allows us to transform cells into structures we wanted while minimizing damage to them. This device is the best of its kind in the world in terms of printing cells into 3D, as well as working compatibly with other biomaterials.
This development is certainly cutting edge, but Chinese researchers say it's still in its early stage. For example, they say it's more complicated to print out solid organs like livers, hearts, and kidneys, and it may take quite some time to apply to hospitals. Patricia Wu, CNN, Atlanta.
A reminder of how we should look after our health, with A&Es everywhere feeling the strain, particularly at this time of year. There's no doubt that organ transplants save lives, but waiting lists for compatible donors can never be short enough. So what if there were a way of producing compatible organs on demand? Bioprinting has traditionally meant printing biocompatible materials as a base for cells to grow. Though it may sound far-fetched, scientists have already managed to print a human ear and other tissues. Doctors take a scan of the organ to create a 3D blueprint. Cells are then taken from the patient, which are then placed in a culture to multiply. The cells are then painstakingly placed on the 3D printed scaffold, which is then incubated to produce a functioning organ. 3D bioprinting solutions opened its labs in September 2013, with the sole purpose of advancing tissue engineering. Supported by the Moscow Department of Healthcare and in vitro labs, the Skolkovo resident should soon have all the equipment necessary to manufacture organs. It's also working on a revolutionary bioprinting technique. The method still requires the 3D printed cell molds commonly used to store and grow various cell types, but crucially, it no longer requires the scaffold around which they are placed.
In 2014, Russia will have its first 3D bioprinter. This will far surpass any previous models, as it will be produced using nanotechnologies. Its speed and accuracy will far exceed that of any of the current models. And perhaps most importantly, it won't even be that expensive.
Traditional tissue engineering methods involve removing all the cells from a dead human or animal organ, leaving only the protein scaffold, which is then repopulated with stem cells and incubated. Mironov has taken this a step further and has come up with a method for printing an organ directly without the use of any organic or artificial scaffolds. It involves extracting stem cells from the patient's fat tissue, which are then mixed with a hydrogel and placed in 3D printed molds. These are then incubated to produce spheroids, which are the building blocks of organ printing. From here, you can pretty much print any organ you like.
We do not use animals or any synthetic polymers for support structures or scaffolds. We only use hydrogel.
The hydrogel is 99% water. It contains the spheroids, which are each made up of tens of thousands of cells, together making the bio-ink used to create organs. The printer lays down a layer of biopaper onto which the cell clusters are printed. Cells of the same type are naturally attracted to each other and combine to produce tissue. The process continues in this way, layer by layer. The biopaper eventually dissolves and the layers fuse and self-organize to produce a fully functioning organ.
The simplest tissues are those that don't have blood vessels in them, such as cartilage, skin, bones, and so on. The organs that we really need are kidneys, livers, hearts, and lungs. But that may only be possible in the distant future.
Although printed organs might not be here quite yet, doctors can already do some pretty impressive stuff. Stem cell therapy involves using new adult stem cells to regenerate damaged or diseased tissue. It may still be in its infancy, but doctors believe that the treatment has the potential to treat anything from spinal injuries and cancer to baldness and missing teeth. Heart disease is one of the biggest killers there is, with heart valve transplants running into tens of thousands in Russia every year alone. Thankfully, Penza-based Med-Inja's pyrolytic carbon heart valves are indistinguishable in terms of performance from the real thing, but provide the long life offered by artificial ones, giving many people a second chance. Bone implants are now commonplace, but that doesn't make them any less advanced. Porous nickel-titanium alloy is a promising new material that's flexible when cold, but snaps back into its original shape at body temperature. But, just like soft tissue organs, bone implants also need to be accepted by the body, so they're given a special coating.
The surface coating should have the exact same composition as bone, so that the body doesn't reject the implant once it's inserted. So our task is to minimize the difference between the bone tissue and the implant. Ultra-thin calcium phosphate films do this perfectly.
Calcium and phosphate together make hydroxyapatite, which is a natural component of bone. The coating is applied by a process called physical vapor deposition, where calcium and phosphate are vaporized into a plasma, then condensed into a thin film onto the implant in this patented vacuum chamber. The whole procedure takes several hours, but the finely tuned ratios ensure the long-term success of the implant. The atoms gradually dissolve, stimulating bone growth around the implant, which results in a solid, natural bond.
As well as modifying bone implants, we have started researching ways to make ultra-thin coatings for coronary stents. As we all know, any malfunction of the cardiovascular system could be lethal. That is why searching for new ways to prolong the life of the patients is of utmost importance.
Stents are small mesh tubes that can be expanded to keep weak or narrow arteries open. Unfortunately, delicate arteries can be damaged during the implant operation or subsequent expansion. So, to avoid complications after the operation, the stents are coated in titanium nitride oxide, or TiNO for short. The super smooth coating helps avoid arterial damage and promotes healing, significantly reducing the risk of blood clots forming or the artery collapsing again later. The coating also remains intact as the mesh tube is expanded within the artery. Just like bone implants, the stent coatings are applied using the PVD process.
There is so-called early thrombosis and late thrombosis. The stents currently on the market guarantee successful treatment for older patients with early thrombosis. But there's increased risks of late thrombosis occurring even after several years. Our preliminary findings allow us to predict that we can avoid both early and late thrombosis.
Given all the medical breakthroughs we've already made, and with 3D printed ones coming in the not too distant future, hopefully we'll be able to start worrying less about our health.
Tiny brains in a lab. Tell me that's not the coolest thing you've heard all day. Hey folks, you're watching D News and I'm Lacey Green. The art of growing human organs may sound like something straight out of a science fiction movie, but it's real, it's legit, it's alive! Sort of. Researchers at the Institute of Molecular Biotechnology in Vienna have grown hundreds of small structures made out of human brain tissue, roughly matching that of a 10-week-old embryo. The pea-sized structures are called cerebral organoids, and they're the first to showcase many key features of the developing human brain. However, the regions aren't organized the same way a normal human brain is. The tissue is distributed a little differently, and it's kind of a hot mess. But hey, we're taking baby steps here. What they've so far accomplished has a lot of applications, particularly when it comes to understanding disorders and developmental issues that occur during the first stages of life. For instance, they're already looking at a brain disorder called microcephaly, where the brain doesn't grow to the proper size. The dorsal cortex, which is the region most affected by the disease, is conveniently very accessible to the researchers now that they're, growing it. By studying the organoids made from a patient with microcephaly, they've already learned that the neurons are differentiating too soon, which may be the cause of the disease. Bam! Life-altering knowledge. So for all of this science magic, you can thank your stem cells. Those of you familiar with stem cell research know that they have the potential to turn into any body part. There are two types, embryonic and pluripotent. Embryonic stem cells are a little controversial because the 40-year-old embryo that they're taken from is destroyed in the process. Induced pluripotent stem cells are usually skin cells that are chemically reverted back to resemble the embryonic stem cells. In the the case of cerebral organoids, both types of stem cells were used, although there wasn't much difference in the outcomes between the two. Growing human organs from stem cells is an area of scientific research that is really rapidly growing all around the world. In 2006, the first full organ successfully received by a human was a bladder engineered from their own cells. Various types of skin cells are regularly grown and grafted on a patient's body. Just this year, a trachea was grown and implanted into a toddler who was born without one. As we speak, scientists are growing blood vessels and veins, heart tissue, cartilage, tiny livers, and lungs. That's right, folks, the future has arrived, and it is sweet. This research has the potential to eliminate so many problems with the organ shortage, because we can just throw them. No more dying, waiting in line for a donor, no more sacrificing your organs to save someone, and because the organs are genetic copies grown from the patient's own cells, no more organ rejection. Science, everybody. Science! Thanks for joining me for Do News. What do you think about the stem cell research and the study of tiny brains? Let me know down below. And we'll be back soon because we got more science updates coming at you every day, twice a day.
Tu sabes o que é homem? Homem não tem preço. Tu sabes o que é hip-hop? Se é pra morrer, morremos de pé. Se é pra morrer, morremos de pé. Se é pra morrer, morremos de pé. De pé. De pé.
Morte do meu pai afundou-me no alcoolismo. Tu sucumbias se vesse o meu transtorno. Querem que eu faça música no meio do cataclismo. Eu tive perto do abismo sem retorno. Chegue, viu minha aura dissolvida. Não vou dizer aqui aquilo que fizeste por mim, X. Viste a minha paz absorvida pelo desgaste. X, salvaste-me a vida, tu sabes. Tava em silêncio a viver a minha miséria. Decadência funérea como dezembros na Sibéria. Eu vi a vossa caminhada para o universo pop. Eu vi como emporcalharam o hip-hop. Bué sons de brisas e primaveras. Até curto sons de amor, mas bro, tu exageras. Com jeitinho faz beicinho, exibe autoestima. E acaba esse videoclipe com um beijinho na menina. Piroso do caralho, prodigioso para eles, para nós mais um paspalho. Crónica ânsia para ser estrela propalada. Quer ser a estrela mais falada, com música mais badalada. Queres ida calada até a ascensão supersónica, com essa salada sinfónica de baladas radiofónicas. Piroso do caralho, és mesmo o tipo de MC excrementoso que eu estraçalho. Como se a cultura tivesse sido subornada. Estamos sem voz há muito tempo, nação desgovernada. Letras eram granadas, agora são gangranadas. Rap burro, não temos opinião sobre nada. Manos em Angola perseguidos por ativismo. Geração Snapchat ancorada no narcisismo. Ser a guerra mundial entre ocidente e jihadismo. E nós com rimas de ostentação e materialismo. Hip hop em chamas tem que ser o MC bombeiro. Dizer que somos azeiteiros, vendidos é lisonjeiro. Antes sentias o frisson do nosso rap guerrilheiro. Agora já fazemos alianças com quizombeiros. Observa as sinalizações e o teu estilo de prostituta nessas ritualizações. Nós só queríamos saber de rimas e inovações. Agora só preocupados com visualizações. Tu viralizas enquanto vigarizas. 10 milhões de views, mas quem é que visualiza? Essas mesmas pitas atadas na alienação, desesperadas por atenção, descascadas no Instagram. Nunca conquistas a fama, tu és só cobaia. Capas de revista, deixa isso para a maia. Deixa a passadeira vermelha e essa azáfama. Globos de ouro, deixa isso para a Ágata. Falo sem superioridade moral. No passado em momentos também fui paradoxal. Faltou-me essência para manter a dissidência. Faltou-me cadência, firmeza, coerência. Mas estou de volta para dar a reviravolta. De volta ao rap de revolta, pronto para qualquer embate. Não há empates, de volta ao rap com tomates. Não há derrotas, de volta ao rap de combate. De volta à nudez e de volta à rudez. Outra vez de volta para acabar com tanta mudez. Outra vez de volta com o feeling do rap português. Sem porquês, morto ao rap burguês. Como um bruxo com capucho na cabeça. Rimamos pobreza, hoje rimamos roupas de luxo. Muito rap meigo, muito rap murcho. Não se poupa cartuchos, estou de volta ao rap sujo.